Yeah, the fourth degree polynomial and its derivative and the quotient thereof divided by this root are only necessary right now to find this 5. So I think I should not calculate it until I need this 5, which is at that point. However, it has already been calculating it 2 times before that. So at least one time too many. Let's see if we can yeah. Ninja, dude. You're giving up on going to bed earlier? You said you were like 5.5 hours later, or that's it's 1:30 a.m. Oh, you said 5.5 plus 3 hours. Okay, so you're already oh, I see. That's why. Yeah, sorry, man. I guess I don't know how you get your notification that I'm streaming, but like when I said you should turn your phone on silent, I meant you can go to settings, sounds, I guess, and then just tell it when you are sleeping. You know, you sleep from then till then, and then it will make no sound whatsoever. Also, no notifications that I am online, starting to stream. Just a hint. Yeah, I'm just trying to help, you know, really. If you really don't want me to help you like this, then I'll stop. It's your life. I won't say anything about it anymore then, but... Yeah, anyway, I wanted to stop generating this fourth degree polynomial unless I really need it, which at the moment it prints is reached the message. Oh, I added an empty line. Yeah. It's already needed here. We're calculating the quotient here. which is based on the derivative, which is based on the fourth degree polynomial. Strange. Yeah, maybe I'm only doing that to get this scale value here. Up step is already known. Oh, I'll also need to know if there is 2 zeros. Yeah, I can't know that. It's a bit a chicken and egg problem. Okay, maybe I need a better way to figure out an initial scale. But yeah, then I can do it if this is true. And then after I did it, check if you have 2 zeros. So I'm going to set scale to that value for now, initially. And I think it's probably already set with that. Oh, it's set with this. It's already set then. It's even better than this one. I want to use this as little as possible. I'm going to change this one by scale. Yep. So we start with that value. And then I use 1/10 of that to see if we get close to an extreme. Although, no, I don't want to do this. I don't want to do this. I want to do this. I'm gonna go 0.01. Then calculate the quotient and the zeros from that, plot the quotient. Number of zeros is 2. I set a new scale. So if the absolute step is still less than that, is this just keeps holding true despite that I set it again. Then finally we can print up the minimum is reached. We set the scale again, different value. And then the question is, so the approximation is used for, well, to calculate the derivative. I think only to calculate the derivative. AKA here. This is just a drawing of it. This is a parabola approximation. The approximation is needed. Derivative. That is here. The derivative is used, well, it is just drawing again. And then the derivatives is used to calculate the quotient. So yes, I don't need to do this until this point. So let's delete all this. And there is a problem with the plot fitter. I think I should use this type as well then here. See how that worked again. Yeah, I can do this. Add Bezier fitter instead of create Bezier fitter. So we make this a plot. And I'll call it as well a plot. And we can go do solve. Not approximation curve. No, maybe I should call that approximation curve. Plot the approximation curve, solve. Plot Bezier filter. This now must be an assignment. And this must be add. And then this must be... No, wait a minute, this must be nothing. And then this is nothing again. Good. So now the solving and the drawing happens here. We can move that one down then. Oh, this uses approximation. Well, you can also delay approximation then. Can we not? Derivative, this uses approximation as well, of course. Yeah, it's the drawing that it should move down. Parabola fitter still there as well. I think I need to do that always. Not sure. Parabola approximation. I probably need that. Every step, yeah. So let's print it as well then. Like that. Pillar repeat approximation. Hey, Fitman. You hate it? Oh, this is not good. Can you just not do it? Is it for a project of your job? Do we already get there? I guess. Okay, I guess. So what happened is the scale was set to the full width of the window. And apparently this 2 is already... Now, rather the difference between 2 and 3. 3 is not drawn yet. That is kind of annoying, I must say. I think 3 is known here and it's printed and it's why is it not drawn? I think I'm going to add drawing 3 sooner, so this corresponds more with what is happening. Let me see. So it's prints this arrow, and then the learning rate is now. I think at that moment the position of point 3 is known, and then really I want it to be drawn already. Let me investigate that. So this is shortly after we calculated the new W, and then it's hanging here until I press space. But yeah, that's kind of silly because immediately afterwards it is adding the calculated W to my history, which then also draws it. So it seems to make more sense to do this already. And then wait. Yep. Which means that I need to put it outside of the loop. Actually, I can't even assign it. I'm going to do this history outside of the loop. Initial sample. And then I move this to the end of the loop. Yep, so now it starts. Okay, I'm not happy with this here. Damn it. Because it draws the second point, but the red line here is only based on the first point. Where exactly do I want to wait for the space? I think I want to wait for the space just before it decides where the next point is. And it makes that decision based on, well, all points, so including this one. And now type space is going to draw a parabola through these 2 points. And then reveals the decision of where the next point comes, which is just the bottom of the parabola. I would rather see the parabola first and then press space and then get to see the 2. And not just get to see the 2, but not even calculate it. So basically I want to continue into the loop. Yeah, it completely depends on everything. Yeah, okay. Maybe it's not that bad, actually. I just have to make a mental shift. Okay, mental shift done. So what is happening now is we have this point 0. The tangent is the red line. And then based on the red line, we go to 1. Which means that it is just... It just made a small step in the down direction of this derivative here. And then I can press space, and then it has determined a parabola that goes through these points. Those 2 points, well, actually it goes through 1 with the derivative equal to the derivative in 0 and 1. The derivatives of the parabola equals the derivative in 0 and 1. And then it determined the minimum of the parabola, which is here. So that w value then plugged into this function, and then we find 0.2. And yeah, all of that is visible now, so why not? And then if we press space again, Yeah, what is confusing is now that it did fit a fourth degree polynomial using points 0, 1 and 2. And it did that because point 2 was already very close, I think. Or the distance between 2 and 3 are very small. So I thought, well, maybe we reach it. I think that's it, yeah. But why do we go to 3 then? 3 is just the minimum of the last parabola again. Okay, 2. Okay, that happened. Yeah, no, I get it. So now it did draw again a parabola using points 2 and 3. No, using points 1 and 2. Using that parabola we find 3. And then the distance, the step from 2 to 3 is small compared to the total width of the graph. Therefore, it thinks, hey, well, apparently we made it. Well, the step is so small that we're probably in the minimum now. And then it determined a fourth degree polynomial going through 1, 2, and 3. Well, it's again not true. It goes through 2 and 3, and the derivative of 1, 2, and 3 are equal, something like that. And then the derivative of that is the whatever the color is here, and then that divided by this root number 3 gives the blue one. And then the scale was changed to the roots of the blue one. So the scale was changed from the total width to the distance from here to there. So the scale got smaller. And then it said, oh, wait a minute, the step from 2 to 3 is not 1/100th of this distance. It was of this distance, but not of this distance. Therefore, I'm not accurate enough, and we're going to use the parabola again to make a next step. So if now I press space, we should get a 4 here in the middle, at the minimum. Yep, I see clearly a 4 here. And then that, of course, was now smaller than 1/100th of this scale. Therefore, it determined again the fourth degree polynomial and the derivative and the quotient. And now the scale didn't change because it's almost the same thing as before. Therefore, now it's still small enough. And then it says, okay, now we're going to jump to point 5, which is the root of this blue thing, but that equals the root of the orange thing, and therefore equals the maximum here of the fourth degree approximation. And that caused us to go to 5. And then it added one more point, number 6, simply by making a little step again, just the learning rate thing, except that now it's going uphill instead of downhill, because this one also investigates maxima if they exist. So if now press space, it's going to plot a parabola through 5 and 6, which then gives me 7. And the scales to still be small. So this time I expected to... No, I didn't. I think I reset the scale to the full width. So I did the same thing. It recalculates the fourth degree, etc. And then throws it away again. I don't want that, of course. It's the same thing as before. I think I should just keep the same scale. This is a good scale from here to there. And again, yeah. Okay, so I'm a little bit confused because I thought I eradicated. I only use this is the full width of the graph, and I thought this is the only place I used it, but no, it's not. So I'm resetting the scale here to that width, which probably I just should not do that. I think that's the only place. It's kind of nonsense even. If the number of zeros is 2 here, then I set the scale. And then I use the scale again, and because I just changed it, we fail. I mean, the same test is done here. So the step was 1% of the scale. Then I set the scale to something smaller. So and now this fails. But if it doesn't fail, then yeah, I just set the scale. There's absolutely no reason to reset the scale again. Just completely remove this. So now it does it the first time, I guess. So it does this, throws it away, do it again. But now we get here, it doesn't. Now we get it, and it immediately uses it. So it really calculates those polynomials now once per extreme. Okay, and then what I was really doing is, now I'm only drawing it when I use it. Well, I should only calculate it when I use it. So let's move the actual calculation of the polynomials also down to where they're being drawn. So this is the fourth degree, this is then the third degree derivative, and this is the second degree quotient. The derivative divided by w minus the root we found. They are defined here because they need to be in the scope of the big loop. Because if destruct this, then the parabola, sorry, the curve is just removed from the graph. But they are assigned. They are assigned down in the code, and I'm going to move the calculation of these things there as well. Starting with maybe the quotient itself. I think I moved the quotient already down. My quotient is calculated here. Okay, yeah. So we have to move everything here, and then I can use it. Now the quotient is calculated here, but it is using the derivative. So I might as well move the calculation of the derivative down here. Let's see where the derivative is determined at the moment. Here, I guess. That's quite simple. Simply the derivative of the approximation. No, we can only plot it after calculating it. And then the approximation itself, which is a lot more involved. No, let's keep this here. This is one very early when we have only 2 samples. So that hardly happens at all. And then once we have 3 samples and 4, 5, 6 samples, and I use the last 3 samples, and then this is actually good. So all of this should be moved. However, I do want to calculate the parabola approximation, which is calculated from these values, the history, and calculate W. I think that's the W that was calculated the last time before we went to the top again. This can be done anywhere. I mean, it's not using this part of the code. So I can just move all of this away here. Previous is used, I think. Okay, let's add that back then. Yeah, previous is needs a duplicate here. Let's paste it here. 32 lines. Move this back. And then I want to move all of that again, but this time including setting the coefficient number 0 and printing in. Okay, so now get a reference to the current sample and the previous sample and previous sample. Those are the 3 points that we use. Create a matrix, solve a matrix equation, define, offset the coefficients of the set the coefficients of the approximation without setting coefficient number 0. So then using these 4 I calculate the value and then subtract that so that after setting this is just a constant. So by setting it like that, this becomes the value at W, which of course is exactly what we want. Just a vertical shift. And then it's calculated. And then we can draw it and show it and use it. Okay, now I was missing a previous. Let's see. I'm doing that a lot, making a previous reference. Maybe we should do this one time. So let's not do this here. But before we do this, this can also be moved, right? Okay, no, I'm not so sure anymore because moving it anyway. Wait a minute, I will scroll down too far. Right. I guess I don't have to do this at all, because it's not used when the number of coefficients is 3. So instead, they just assign it directly. To the parabola approximation, which I do need. And this can be deleted. And now this code and that code is just the same thing. So I can make this coefficients larger or equal 3. And this is called parabola approximation, but it also serves as a straight line. So this is assigned outside of it, which then belongs to this block, where I'm only having assigned index number 2. Index coefficient, I mean. Here's another one that can be removed. Yep. I think I'm getting there. I'm going to remove a few of these asserts as well, because they're just silly. They never fired before. At some point I had a bug where I started to add really paranoid a lot of asserts, which never fired. Oh. Now I'm calling previous too soon. Yeah. Can't really do that here, because I only have 1 point in the history, so there is no previous. Yeah. That's why I did it so often, because only certain scope. So here it doesn't exist, and now here it does exist. But if I have, this I already deleted half the code here. So we can do it here, and then we do it again, where it now is not defined below here. So I'm needing it here, but let's see, I can already do it here. Number of coefficients is 5 even. Dude, we so have a previous, and I need it also here. I'm gonna assume that I do not use previous before this, hopefully. I do. Okay, so I have to repeat it again here. Coefficients 3 and 5 needed. That should be enough. and everything broke. Really? Why? Minus 40, and this is bullshit. That is bullshit. Skill was set to 80. What's the initial skill? Oh, okay. Initial value set to 80. Why do I not understand why it broke? Often I just, it breaks and then I immediately understand why. So again, we have this point, the tangent is that, following down that tangent we get point 1. Next step is fit a parabola, that clearly still works because it's the same parabola. The minimum of that gives us 0.2. Definitely works. So this is 0.2. We went from 51.58 here to 49.03 here. Now I'm going to click space again, and what happens then? I don't see a sensible point being added. We had 0.2. It says minimum reached, okay, or could be that it thinks that temporarily. Delta is minus 48, that's wrong. That's why everything goes there wrong, I think. Grid label 3 at 49.03, so 3 is set, okay. Because we found a minimum, it's duplicating the point that is closest from the whole history, that is closest to the new point. And the new point is, I don't see the new point really. Oh, these two zeros. Yeah, okay. Nah, I don't know, but yeah, nah. I guess using 0.01 and 2 suddenly gives me this polynomial with this derivative and this quotient. So the roots even fall outside of the graph, so far away they are there. And then it picks one, which is not good. No, not good at all. Okay, it picked one. I don't know which one. To pick one of those. Guess it picked this one. That's why we have a minus 48. Let's add more debug output. So we have... I want to see which zero it picks and why. Oh, that's why it stayed 80. I use the standard minimum. Yeah, this is already super fishy. That was even necessary. No. Yeah, I'll do this. Let's use A, the A of approximation. I already know that it's the case now. Don't even have to test that. Do sports. Yeah, 0 is that one with A is 28, the other is way up. Okay, whatever, yeah. Which is totally coincidence, of course, because... What, 28? What? It's like a sinus, it goes up and down between -1 and 1. Oh, 20, oh yeah, right. 28 is the approximation. So the teal thing here that's going up is apparently 28 around here. Yeah, it's just not a good approximation. Not at all. This should be detected instead of continuing with it. Okay, but before this didn't happen. Not at all. I think the difference is that now it has decided that the 2 is already at the minimum. And therefore it's doing a 4-degree polynomial fit through 0, 1 and 2 instead of through 2 points that are close here at the bottom. And apparently that doesn't work. Ouch. Why does that not work? Is it just is that so bad that we are a little bit off? Apparently it is. We're just not accurate enough. Not happy there. And the only thing I just moved the calculation of the I moved the calculation of the approximation and its derivative. This should not there should not have been any difference at all. That is, this is true, and then Excusez-moi, I mean this. This is true. And then we should change the scale. Hell, even no. Even that. It is just like it doesn't work anymore. Something changed. No, I want to go back before the last change. I did not commit anything to Git. That is not possible. Sitting in the dark again. Hate it. If I call add, then the added label is the previous total number of samples after we return at least, because it was incremented. So I call add, and then the current label is what we last added, is equal to total number of samples minus 1. That is, this is the step between what W was and what is W now. And W was W is just the current value. W is the one that was just added. Oh, gotta be kidding me. Current W is previous W. Okay, very confusing, Carl. Let's just, oops. So like I said, I sit in the dark. Can't see my keyboard. It's annoying at times. I had my hand on the wrong keys, so touch typing problem. Okay, so it says up step. Dit is not correct, is it? It is so weird. This distance is like 1 point, I don't know, 5.5. No, more. 2.55. Distance between 1 and 2. So definitely not 1 and 2. And then I think, well, then it's probably the next step. Which means, where's 3? We don't have a 3 yet. There was no 3 calculated. Where the hell did it get this difference from? Nope, there is no 0.3. Is W changed again after this? Okay, I guess I have to print every time W changes now. That is the right value. That is where the absolute step came from. But it was never added. That's kind of strange. Approximation. Immediately. Oh, wait a minute. Oh, wait a minute. Wait a minute. Okay, I understand what's going on. So I find a new step and then calculate approximation at this point already, basically, while I didn't add it to the history yet. So it takes the previous 3 points, not the new, it does not take the new point in account for some reason now. And then the approximation is bullshit. Well, at least it is bullshit, but that's why it wasn't bullshit before. Now this doesn't make any sense. Why would that suddenly be equal to the absolute step? So this should be 1, 2 and 3. And then 3 should be added to the history before we start a calculator approximation. Mm-hmm. Yeah, here I'm using W instead of current power, so current W. I'm just assuming that W was already added, but it's not. I still can't wrap my head around it. That I just moved this calculation and suddenly it's completely off. But it seems to be the problem. W should have been added to the history at this point. I wish I understood though, because without understanding it's hard to get code right. Unbelievable. W plus step. Still don't get it. W is 0. That overrides the previous value of 0. That overrides the previous value of w, I mean, that we just said. Yeah, I think this is firing, right? This is firing, isn't it? Yes. I think it should be firing. Yes, it is firing. Okay, I'll let that assert fail. That's at least something then. And that kind of makes sense, yeah. That kind of makes sense, because I did move that code over the change. This code was moved beyond, from before to after this point. But I guess that kind of means that there was a bug already then. That I did not add that last point to the history. I mean, this point was never added to the history. Yes, I think that is what's going on. This point was never added to the history, and using the previous point did work, but now I'm changing W so that it a little bit even, but it's no longer equal to the current, and therefore I corrupt my matrix, because I'm using a different value here than I'm using for the squares and to the power 3, and that then gives the nonsense. The solution is then to, well, I guess fix the old bug, which then also not only stores it, but also fix again that this is holding. Okay. My washing machine is beeping. Hold on. I'll be right back. Right. Yeah, Omar. Only think I should go to bed though, or stop streaming anyway, because it is 10 p.m. I'm trying to shift my day. Let me just finish this quickly. Now we're talking. Oh. Now we have absolute step is 0.47769 between 2 and 3 to be added. Appended to history 0.3, 49.508. And 0.2 was 49.0303, which is indeed that far apart. So I think now it makes sense all the way up till here. And then we have an approximation, which is now correctly calculated. At least that's a nice fit here. Very nice fit. And appended to history, approximation, derivative quotient with zeros 40 and 57. Skill set was 17. 0.4 is at 49.5 because oh no, it's a duplicate, I think. Yeah, it's a duplicate of 3. Skill is set. Okay, the skill was changed, so it skips detection of the minimum. Yeah, it's doing the same thing again. Oh, fuck? Really? This is failing big time. Oh. Oh. Yeah, I'm getting it. Finally. Finally a bug that I understand. So the problem here is that... Well, no, I'm not sure anymore anyway. I thought maybe I got it, but. No, I'm not so sure anymore. Well, I saw it adding a duplicate, but that happens here. No, it didn't get here. This if failed. Oh, right. That's it. That's it. I'm adding it to the history. Then it fails, and then it gets added to the history again. So it was already added. So maybe I should not add it to the... Yeah, I should add it to the history. But I should only add it to the history if this succeeds. So maybe... So I should add it to the history here. Which means that I can't use the history the way I'm using it at the moment. Which is only here by setting current and previous. Which I'm sure is only used for the construction of the matrix. Yeah. Right. Yep. And current. Current as well. Current is used here. Okay, current is used here, but that is after this point. So you could add it to the history here instead of here, and that would solve problems. But then these two are not correct. But I have to do that anyway. So let's move this one down to that point. Actually, polynomial. Right. And now I want to use W. This must be W times W. And this is W. W times W. But I use that here again, so maybe I should use this is no longer holding. Squared w to the power 3, and here we have w to the power 2 and w to the power 3 and w to the power 4. That is current, so no more using current, but actually I'm using previous, and previous is current. So I think previous is not being used now. I should use previous, but I already have previous. So we should replace previous with current now. No, wait a minute. Current. This previous current. And then previous becomes just previous. And here's again a previous, which must be a current. And here's a previous, which must be current. And then here I have a previous, which must therefore be a current. And the DLDW is not calculated. Okay, this becomes previous. This becomes current. And then I think I have them all. I hope. Except DL and DLW. A minute. Okay, well then I do this calculation double, but yeah, can't be helped, I guess. Well, it can be helped. I add a boolean around this. And I might as well have added a boolean around that one. And I didn't want to do that for some reason. Fuck. I'm going to